Make sense now? I mean, the other explanation, Eugene, I don't know what is H squared. I don't know what it said. I'm going to use what I know. Okay, I'm going to sidetrack a bit. Okay, I'm going to sidetrack a bit. Watch this. It is the same as static analysis in bending moment. I repeat again. It is the same as what? Static analysis in what? Bending moment. What do I mean? If now I have a structure looking like this. This is fixed into a wall. Then this is your X. This is your Y. And this is your Z. Yes or no? Now I have two moments. One moment is applied this way, and this is our MY. The other moment is applied this way. That is our MZ. Okay. Now I'm going to look at the cross-section view. This is my Y, and this is my Z. This is my structure now. Agree or disagree? When that's the case, how this is drawn, this is my moment about Z, and this structure over here, this is moment about what? Y. Agree? So from here, when you calculate stress X is equal to what? My over what? Over Iyy multiplied by Z plus or minus Mz over what? Izz divided by Y. Now, which is Iyy and which is Izz? The formula for rectangular I, this is equal to B, this is equal to D. The general formula is BD cubed over what? 12. Agree or disagree? Right? Now, which is the width and which is the depth has nothing to do with English. I used to talk in English. Width is smaller, depth is bigger. Garbage. Nothing to do. So, right? So when is it your width and when is it your depth and about which axis? So why is it My, you use Iyy? I'll show you. Why My, you use Iyy? When we look at now, I'm now going to look at the structure this way. So this is my X, this is my Z, coming up is your what? Is your Y. Now, if we were to draw this structure, the structure look like this. Yes or no? This is the thin portion. And then this is your what? MZ. Sorry, MY. When your MY deform, your MY will deform about where? It will rotate. This is your what? Y-axis. Yes or no? It is rotating about your what? Y-axis. That's why you use what? Iyy. Can you see the relationship what we are doing today? Yes or no? Right? The wheel is rotating about Z-axis. We use what? Second moment of mass moment of area in the what? In that direction. Are we clear? Same thing. How the structure is what? Rotating. You see the link now? Yes or no? Okay. That is why you have that. Now, the confusing for most students is which is the width and which is the depth. Agree or disagree? Are you confused or not confused? Not confused? Yeah, good. So some of you are confused. Let me give you a trick. So if we look at our structure, this is our what? ZZ. Okay. I call this my A. I call this my B. Okay. So when I do IZZ, you have width multiplied by depth cube over 12. Okay. The axis of interest is where? Your ZZ. Okay. Your axis of interest is your. If that's the case, this direction will be your width. This direction will be your what? Your depth. The width is always parallel to the axis of interest. The depth is always what? Perpendicular. When that's the case, the width for this case is A B cubed over 12. It's always dependent on the axis of what? Interest. Nothing to do with English. This is width and this is depth. Are we clear? Okay. So if you are interested in your IYY now, when that's the case, this is known as the what? Width, right? Because the rule still stand, the width is always parallel to the what? Axis of what? Interest. And then when that's the case, over here will be your what? Will be your depth. So this is still A and this is still B. So IYY is equal to BA cubed over 12. That's it. Your axis of interest. Over here, coming where we are, IZZ is our axis of interest. It's because the wheel is rotating about where? The Z axis. In bending moment, the structure is rotating about Y axis. Are we clear? Or Z axis. Okay. Are we clear? That is the only reason. I'm going crazy. Okay? Why I'm going crazy? Yeah, I'll tell you guys later why I'm going crazy. Right. So from here, we are going to find our IZZ. Who is that? Is that me or is that you? So from here, IZZ is equal or to half multiplied by our mass of what? I forget what is our question now. Shoot. Of 50. And our radius is 1.5 squared. Okay. Is it our mass 50? No, our mass is not 50. Our mass is 50 divided by what? Divided by 32.2. So our IZZ will be equal to 1 over 2 times by 50 divided by 32.2 times by 1.5 times by 1.5 is equal to 1.747. Okay, it's equal to 1.747. So now we bring everything back here. Okay, so we bring everything back here. Okay, we bring everything back here. Control C. We bring everything back here. Right, so you have minus 38.971. This will be equal to 50 divided by 50 divided by 32.2 times by 1.5 minus 2.3 2.330 AG alpha or AG X, and we calculate our I naught or IG is equal to 1.747 kilogram, not kilogram, slug feet square. So 1.747 alpha. Okay, so from here, we know the next thing we know is we know that A G X is equal to alpha multiplied by R. So the radius is equal to 1.5 alpha. So we have minus 38.971 is equal to minus 2.330, 1.5 alpha, 1.747 alpha. So this will be equal to, I just put down what is alpha, okay? So alpha is equal to 7.434 radians per second squared. And then we can calculate our friction force is equal to, so friction force, we are going to use the expression that we have derived, is which is equal to 25.981 minus by 1.553 AGX, okay? So this will be equal to 25.981 minus by 1.553. Then you have, so this corresponds to alpha R, 7.434 multiplied by 1.5. So this will be equal to 1.553 times 7.434 times 1.5, 5.981 minus 8.66 pounds. And then finally, AGX is equal to 1.5 multiplied by 7.434. So this is equal to 11.151 feet per second square. Okay. Now, I think I would like to remind you all this. Okay. I think today I have to clarify this, or not I feel really guilty. When something known as free what? Free spinning. Okay, the wheel is known as free spinning. When this is the case, friction force is equal to 0. Okay, so no, I will not create that joke. It's pretty bad. Then you have a case where you have what? You have a case where you have no slipping. When no slipping, A is equal to alpha R. And when this is the case, friction force is not equal to what? And the third thing to remember, when we have slipping, right? Then when this case, alpha is not equal to alpha R. A is not equal to alpha R. However, you can use FF is equal to what? Come on, Eugene, write properly. Are we clear? I'll see you guys. Okay, thank you for your time. Thank you for your focus. I really appreciate a lot. Next week, Friday is the